Hi, students. Let's look at this question, which is on proof of plane geometry. Let's see how we can do this proficiently. So the diagram below shows a circle with two perpendicular chords PQ and RS meeting at T. Okay, given that the radius of the circle is R, okay, show that PT² plus QT² plus RT² plus ST² is 4R². Okay, great. I think there's a lot of things going on there. So what we know is a PT², which is, so let's just look at this length. PT² is this guy here. PT, then square. Then we have got QT square. But I mean, the most important thing is TS square here, because this will form what do you call it? If this is 90 degrees vertically opposite angle, so this would be actually by Pythagoras theorem, right? So we know that PD square plus ST square is equals to PS square. Similarly, you look at I'm just trying to understand which side of the line segment is important. Okay, so then we have QT and we have RT. So QT and RT, this will give us this by Pythagoras theorem here, right? So obviously now by Pythagoras theorem, we know that this length here is important, this length here is important as well. Okay, so I'm gonna just write it down. So with that in mind, actually what happens now is we need to find the radius R, right? The radius R, and how do we relate PS and RQ with the radius R. So I'm gonna just just let O be the center of the circle as usual. Then after which, just draw out the radius, right? So like that. So I'm just let this be a circle is around here. Then what we're gonna do is actually just extend it to the side, right? To get the radius there. So this over here, and to this side, because this is the important one. And similarly, I'm not sure what I'm gonna do. I'm just gonna label to this side as well. Okay, because we know that if these two lengths are important, PS and RQ, they are important, so we need to extend our radius to this side here. So with that, if this is a radius, so we know that this is R, and this is R, this is R, and this is R. Okay, so just look at that. So this is a bit complicated, all right? Then what we need to do is just try and observe, try to relate the line here with this line here, because that's what we want, the length here, right? But let's see how we can do that. I think the first thing is to be able to find this angle here, because if we have this angle here, we could use cosine rule, right, to find the length of RQ. Then from here, what we can say is that angle at the center, this is angle. Okay, so look carefully for this case here. If I let this be theta, this over here is my angle at circumference, right? This will be my angle at circumference, right? Because this angle at the center is twice the angle of circumference, so this is by theta over 2. Okay, so once it's theta over 2, then what we can do is, we know that this is 90 degrees because this is a vertically opposite angle, or I mean this angle, adjacent angle in a straight line, right? So then this angle here in this triangle, okay, will be 180 minus 90, which is this guy here, minus of theta over 2. Okay, then once this is done, we angle in a semicircle, angle at the circumference, and angle at the circumference, and angle at the center is this guy here. So here, you can draw it out. Okay, so this over here will then be twice of this angle here, twice of 180 minus 90 minus theta over 2. Okay, so that's the whole idea. We start off by labeling this as theta first. This is theta, then this is half an angle by angle of the center is twice the angle of the circumference. Then from here, we take these 90 degrees, this angle in the angle sum in the triangle. Then we get this angle here. Then we half it again to twice it to get the angle at the center here. Okay, so then once we have that, then we could actually relate these two angle, this angle opposite of this line and this angle opposite of the other line over there. So I'm going to write the step one by one. So let angle ROQ be theta. So this is theta over here. Okay, then after which we know that this is this angle is theta over 2 by using this angle at the semicircle and angle at the circumference. All right. Then once done, I'm going to put this as 90. Then this angle over here, we can find this angle over here by what do you call it? The angle sum in this triangle TQS. All right. So that's it. So we managed to get 90 minus theta over here. Okay. Then now what we're going to do is using angle at the center and angle at the circumference again over here. So this angle here will be twice of this. Okay, so just twice of this. So once done, what we're gonna do is actually we just gonna use cosine rule, which is a square equals to b square plus c square minus 2b c sine a, right? So this case here, we could just apply our cosine rule to this triangle here to find our PS. Then we could also use cosine rule to find our RQ here. Okay, so that's that. So for the by using cosine rule, we know that in this triangle here we have PS square is equals to POP square plus OS square minus 2OP OS cosine 180 minus theta. Right. Then for this triangle here, we know that we'll get RQ square equals to OR square plus OQ square minus 2OR times OQ cosine theta. So we're just going to combine both of these together. Okay. The beautiful thing is that OR, OQ, they are all radius. So OR, OQ, and OS and OP, they are radius. So we can just reduce it to R square actually. Okay, done. Then now take note. We know that OP equals to OS equals to OR equals to OQ, which is actually equals to R, the radius. And also cosine 180 minus theta. There are many ways to get this. Firstly, you can also think that theta is acute angle. So this 180 minus theta. 180 minus theta is in second quadrant. So this will be negative cosine theta. Acute angle, it will be negative. Because in second quadrant, cosine is negative. Okay? So you just replace this with negative cosine. So note that cosine 180 minus theta is minus cosine theta. Okay. So we can also use the addition formula to do it. All right. So, but anyway, that's that. So this will be reduced to PS square equals to R square plus R square minus 2R times R cosine negative cosine theta. And this is PS square equals to 2R square minus 2R plus 2R square cosine theta. Okay. Whereas for the second one, we have RQ square equals to R square plus R square minus 2R times R cosine theta. Then in this case, we have RQ square. So that's it. Okay, now we have PS square and RQ square. PS square and RQ square, initially we established that PS square and RQ square is actually PT² plus ST² by Pythagoras theorem and RT² plus QT². So we just replace them in. So we label this as 1 and 2 from 1 and 2. So we can reduce to this case here. Then once we're done, I'm just gonna sum them up. Okay, because we need to sum. So 3 plus 4. So the left hand side plus the left hand side. Okay, left hand side plus left hand side equals to right hand side plus right hand side. So you can get this is actually this. Then we have this is actually this. Okay, so 2R square minus 2R square is cosine theta. Cosine theta is just 0. So this will be 4R square. Right? So shown. Just sum them up, then you get what you are told to show. Okay, so that's how you do this question proficiently. If you have any questions at all, please do let us know and I'll see you in the next question.